Hello, my algebra friends. Welcome to class. Today what we're going to do is continue on with lessons in quadratics. Today will require you to pause the video every so often and take some notes. I am highly recommending that you use the Cornell style notes. The big topic of the day is going to be quadratics. So here we go. I will tell you when it would be appropriate for you to pause the video to take notes. Alright, to start with, I know that you probably are already familiar with what independent variable and dependent variables are, but what I'd like you to do is just go ahead and read these two concepts to yourself and summarize them in your notes. Your big idea is going to be quadratic functions, so if you want to go ahead and put quadratic functions at the top of your notes for today. And today's date is October 26th. You always want to have a reference date so you can always go back in your notes. The very first thing that I'd like you to make sure that you do put all of the information in your notes has to do with parabolas. We're now going to move out of our linear world where we've been for the last couple of, months actually. And we're going to be moving into this parabola world. The graph of a quadratic function, a parabola, has a line of symmetry. That line of symmetry is right here and right here. It's either going to go up and over or down and up with maximum and minimum points. Please pause the video at this time and go ahead and get this information, all of this in your notes, and go ahead and summarize these two things so that you have a good understanding. When you're done, restart the video. What I would like you to do with this information is I'd like you to write down what it is that it means for a quadratic to be a function between independent and dependent variables, such that as the dependent values increase by a constant amount, the successive first differences between the dependent values change by a constant amount. I'm going to show you what that means visually down here. If you're looking at a table of values, such as you see here, the first thing you're going to recognize is there's a power of 2. That's your first hint that if your highest power in your expression is 2, then you're dealing with a quadratic. But how can you tell from a table? Let's say I just gave you this table of values. Well, right now you know how to check for linear functions, where you would see that if x is increasing by 1, is y increasing or decreasing by a constant amount? And if yes, then you have slope, rate of change. Well, in a quadratic, what you're going to do is you're going to look for your first differences as you're moving up y as compared to x moving up by 1. If you don't see a constant rate of change here, then you know you don't have a linear function. It could possibly be an exponential function. It could be a quadratic function. Not quadratic function, but exponential function. It could be linear function, and we had inverse functions. So go ahead and find the second differences. That means take these first differences and find the difference between each of them. If you generate a constant, that's another way to determine that you have a quadratic function. Please pause the video at this time and write this information in your notes. I highly recommend at least the first sentence here. Jot some examples and put down the example of what it means for first and second differences. Restart the video when you're done. Some examples. If the parameter a, the coefficient of the x squared term in a quadratic, is positive, and what that means is, see the x squared? If the coefficient is positive, your graph is going to look like this. Always. Don't forget that this is in descending order by power, and you can see 2 is the highest. Therefore, the curve opens upward, and you've got a minimum. If the position coefficient at the x squared term is negative, that means that the position A is negative, then your parabola will have a maximum point and it will open downward. Please write all of this information and sketch yourself an example with the functions in your notes right now. Pause the video. Come back when you're done. Here, we're talking about all aspects of a quadratic parabola. Please go ahead and sketch two examples of the positive and negative coefficients to include their maximum points, their minimum points, line of symmetry, but now you're including the y-intercept and the x-intercepts. Sometimes there's two x-intercepts, sometimes there's one, and yes, sometimes there's even none. Please write this information in your notes, Cornell style. Your trigger word should be to the left, your content should be in the middle. Pause the video. When you're done, we'll see you soon. Critical. This is why understanding x-intercepts and y-intercepts is so important. And understanding that the x-intercept is where y is 0. Because these are going to be your solutions, your roots, all kinds of information is going to come out of this. So what I'd like you to do is, in general, just make sure you get the understanding of what x-intercepts are. Follow this example, this is factoring right here. Follow it along, and then observe the graph. Pause the video, study this, and return when you come back. When you are done with all of that, I'd like you to go to Investigation 1.2. Read the opening information, and then begin the activity with your group. See you soon.